Okay, so here is a picture of an example of one of these graphs. So I want you to pause the video, but think about 3 things that you notice about this and 2 things that you wonder about this. Okay, so pause the video, and in a second I'll come back and we'll talk about some of the things that maybe you notice and maybe that you wonder. Okay, so maybe you noticed that there's a big old break in the graph right here at x equals 1. Okay, going back to our video, this is called an asymptote. And because it's vertical, I can spell vertical, it's a vertical asymptote. Okay, there's also a hole in the graph. Remember, this is called a removable discontinuity. Oh my gosh, of course my computer stops working. Okay, and that is at x equals -2. So there's an undefined point here at x equals -2. There's also an undefined point here at x equals 1. Another thing you may notice, there's a y-intercept at 7. There's also an x-intercept at 7. So this would be 7, 0, and this one would be 0, 7. So those are kind of all the things that we've talked about. Nope, I paused. Okay, there's one more. There is a horizontal asymptote here at y equals 1. So if we look at what this equation might look like, we know that there needs to be an x plus 2 and an x plus 2 in the numerator and the denominator, because that's going to divide out to cause that hole in the graph. We also know that the x-intercept is at 7, so I need an x minus 7 in the numerator, because that's where my x-intercepts come from. My denominator, there's a vertical asymptote at x equals +1, so that would be -1 in my equation. If it's the same degree over the same degree, it's the number in front divided by the number in front for the horizontal asymptote. Well, that's at y equals 1, because it's 1 divided by 1 in my equation here. So that's kind of how you can build it. You can go one direction with it, you can also go the other direction with it. So that's kind of big picture, like this is actually what this looks like, and this is what these vocabulary words that I just talked about, that's where they come from and that's what they mean. So I want you to take a second to solve for each of these. Okay, find the x-intercept, find the y-intercept, find your vertical asymptote, find your horizontal asymptote, and then see if there's any removable discontinuities. So these you're going to have to either factor, or you can use quadratic formula. Same thing with this one, same thing with this one. Okay, so if things divide out, they're removable discontinuities. If something's left in the denominator, it's a vertical asymptote. Anything in the numerator is your x-intercept. And that's kind of how those equations are going to work. So take a second and stop here and try those problems. And I'm going to keep going. Okay, so here are the answers for those 4 problems that you just tried. Make sure that you kind of got the same x-intercepts, the same horizontal and vertical asymptotes, and then wrote them in the correct way as coordinates and not just x equals something or y equals something. This one here, this is how you find the removable discontinuity, and so I'll explain that a little bit more on, or you find the y value of the removable discontinuity. I'll explain that more on the next video on part 3. So there are the answers, check your answers, and hopefully you did well.